Okay, we're starting today with a dot plot. This is a graph that we're going to use with quantitative data. Here I have the 2019 Garnet Valley baseball schedule and the results for the games. Well, it's hard to scroll through and see them. If I want to see them all at once, what I can do is create a dot plot. A dot plot, what you do is you write a number line. And then after the number line, you have all your data. I was using my phone. And each one of these dots represents a piece of data. In this case, each dot represents a game. Dot plots are great for a couple different reasons. They're easy to make, number one. Number two, they give you a quick snapshot of what the distribution looks like. We're going to be describing distributions, and the way we do that is it's very specific. We're going to use an acronym of SOX. And what SOX stands for is the shape, outliers, center, and spread of my data. So the shape of this distribution, there's three of them that we're going to be talking about quite often, is skewed left, skewed right, and symmetrical. This one, the skew follows this tail, is skewed right. The outliers, there's two possible outliers, one here, one at 11, one at 15. The center of this thing, well, let's just count back and forth. There's 24 pieces of data, 12. It's somewhere in here around 2. So then the spread, how spread out, it goes from 0 to 15. That's my range. I just do the largest minus the smallest, and my range is actually 15. So if I were to say that to someone, if they close their eyes, they should be able to envision what's going on there and know exactly what this distribution looks like. The second type of graph we're going to use for quantitative data is going to be a stem plot. So here I have the number of Snapchats sent in a day. And what I do is, since this is just 2 digits is the most I have here, in the first column over here is I'm going to put the tens, and then units are going to go over here. This is the stem, these are the leaves. You can do this with decimals, you can do it with hundreds. There's different ways of doing it. So I always have to put something to represent what 1-2 means. It means 12 Snapchats. Okay, so let's start off with the 0, 1, 2, 3, 4, 5. It's a big 0 for some reason. 0. I have 1, 9. Now what I did was I put my data in order. If my data is not in order, I can create a stem plot with it not in order and then just draw one next to it that is in order. My final one should be in order. I could put my data in order. You can do it in your calculator, you can write it down. There's a lot of different ways that I'll show you how to do that. So the next one is 1, 2, 3, 8. This one is 0, 0. You write both zeros. 1, 2, 8, 9, 0, 5, 7. No, and then a 2. So what I want to show you is if there are gaps, you want to show them. Okay, so there were no 40s. I don't put 5 underneath there. I go 4, 5 and show it. Unless I have something that's really far away like this. I'm not going to continue writing this. Another way I can do it is I truncate it by going like that. That makes the person aware that that's there. And then there's a number way down there at 101. If I'm describing this distribution, if I turn it this way, the thing is approximately symmetrical. Its center is at 2. It ranges from 1 to 101, so it has a range of 100, and it has a definite outlier, 101. So the other type that you can do when we're talking about stem plots you may see is back-to-back stem plots where I have male, female. They'll put the stems down the middle, and then they go out this way. Same way, it's odd to write this way, but I'm going 1, 2, 3, from least to greatest out that way, the same way I would that way, just in case I want to compare male and female. So that's the second type. This is the third and final one that we're going to do for quantitative data. It's a histogram. Now, so far, everything we've done is each individual piece of data. We used a point, we used a number. Well, now, if you have a lot of data, that becomes very cumbersome. So what we do is we create something called a histogram. Now, in a histogram, we create bins instead of one individual piece. What we do is we create a bin, and they call them classes. we're going to go from 0 to less than 5, 5 to less than 10, 10 to less than 15. You're like, well, where did these come from? A lot of times you decide how you want to draw this thing, but these have to be uniform in width, and when every piece of data has to be encompassed. So I have a set of data, I just wrote them out, dot, 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 goes on, number of hits in 2019, let's stick with the baseball theme. And here I count, well, how many of them are from 0 to 5? And there were five players that hit between there. And then I do the same thing for 5 to 10. Once I have these numbers, I go over here and I draw my scale down here. I always want to title it number of hits 2019, and then I want to put down, all right, it goes from 0 to 5, there were 5. From 5, this one went to 8, then to 10, then to 5, then to 2. So you want them to be the same width, and there's my histogram. Over here, this is frequency, so I want to write in the word frequency. Most of the time, they're not done with frequency. Most of the time, they're done with relative frequency, which just means I would write them as a fraction, and then this would go, for the 0.33 would be the highest, so this would just be 0.33 up here at 10. The histogram itself stays the same. The only thing that's changing there is my y-axis. So that's a histogram.